Welcome back to the deep dive. We cut through the noise, give you the essential insights fast. Today, we're tackling something that can feel like a huge mountain to climb. Building a really solid e-commerce site. It's a massive job, right? Especially if you're maybe just getting your feet wet with cloud computing. But imagine sketching out the whole plan first, like designing a house before you even think about pouring the foundation. That's what we're doing today. We're diving deep, but it's all theoretical. Designing an e-commerce solution architecture on Microsoft Azure. So no code, no setup screens, just focusing on the concepts, the high-level design. Think of it as, your strategic blueprint.
Yeah, and that blueprint idea is exactly what Azure Solution Architecture is really all about. It's basically a plan. It shows how all the different Azure bits and pieces, servers, databases, security tools, you name it, work together. For an online store, that means mapping out, well, everything. How users browse, how the cart works, payments, and critically, the stuff behind the scenes too. Inventory, orders, keeping the business running smoothly. It's the whole picture.
Okay, so why Azure? Specifically for e-commerce. What makes it a good fit beyond just being in the cloud?
That's a really good question. For e-commerce, the big things, the real game changers are how it handles those crazy traffic spikes. Black Friday sales, that kind of thing. It just scales up.
Yeah.
And it has really robust tools for securing customer data, payment info. That's huge. Trying to build all that yourself from scratch. It's incredibly complex, expensive. You'd need a big team. Azure gives you a lot of that ready to go, so you can actually focus on your products, your customers.
Right. So it's not just moving servers online. It's using services that solve those specific e-commerce headaches without you having to invent the wheel. Sounds like a big deal, especially for smaller businesses.
Oh, it really is. The pay-as-you-go model is key. You're not buying tons of hardware up front. And the auto-scaling means your site stays fast, even if, say, traffic jumps tenfold unexpectedly. That flexibility, plus how it connects easily to payment gateways, shipping APIs, all that stuff, it lets you build something really professional, reliable, 24/7, without needing to manage physical servers. It really does sort of level the playing field.
Okay. So our mission for this deep dive, we're breaking down the design process, 5 key steps. And we're using Azure's well-architected framework as our guide. Things like reliability, cost efficiency. So as we go, try to picture yourself sketching this out. Whiteboard, maybe draw.io, whatever works. Visualizing this blueprint is really helpful. All right, let's kick things off. Step 1, laying the foundation, defining requirements and the high-level design. Where do we even start when trying to list out everything our dream e-commerce site needs?
Well, you've got to think about 2 main types of requirements. Functional and non-functional. Functional is the what? The obvious stuff. Product catalog, shopping cart, user account, search, checkout. But then there's a non-functional. The how well. Like, can it handle 1,000 people shopping at once? Is it going to be up 99.9% of the time? Are payments super secure, like PCI DSS compliant? And don't forget who's using it. Customers on phones, on desktops, admins managing inventory. Different needs there.
That what versus how well distinction is key. And our sources really hammer home a few critical points here. First, scalability. E-commerce traffic is it's all over the place. You have quiet periods, then massive spikes. Designing for auto-scaling right from the start, non-negotiable. Imagine trying to add servers manually during a flash sale. Chaos. Second, global reach. If you plan to sell internationally, you need it to be fast for everyone, everywhere. Low latency is crucial. And third, compliance. Things like GDPR for data privacy, PCI DSS for payments. It's not just legal stuff, it's about trust.
Exactly. Once you have those requirements listed out, you start sketching. The high-level diagram, just the big blocks, the front-end website, the back-end logic, the database, maybe external things like email services. And here's a tip for beginners. Don't feel like you need to invent it all. Microsoft has great reference architectures in the Azure Architecture Center. Just search Azure e-commerce architecture on their docs. They give you templates, like a basic one might just show a web app, a database, and a CDN content delivery network for making images load fast.
That's a great starting point, using those templates. Okay, so we know what we want. We have a rough sketch. How do we actually host it? Run the code. That brings us nicely to step 2, choosing compute and front-end services.
Right, and Azure gives you a lot of flexibility here. For the main website itself, Azure App Service is often the go-to. Doesn't matter if it's simple HTML, CSS, JS, or a framework like React, App Service handles it. And the best part, especially if you're newer to the cloud, is that it's managed. No patching servers, no OS updates. Azure does that. It handles custom domains, SSL certs, and crucially, it can auto-scale. Then for smaller back-end tasks, like maybe updating the cart or firing off an email, Azure Functions are perfect. Serverless. You only pay when the code runs. You also have things like Azure Static Web Apps for simpler sites, or container options like Azure Container Apps. But honestly, App Service often forms the core, and you layer in things like functions where they make sense.
Okay, so designing this, I might use app service for my main web app and make it responsive, but what about making it fast globally and secure right at the entry point?
Ugh, good point. That's where you'd bring in Azure Front Door. Think of it like a smart global receptionist for your website. It sends users to the closest, fastest instance of your app service. Low latency. Plus, it has a built-in web application firewall, a wave. Protects you from common attacks before traffic even gets near your app. App Service itself handles the HTTPS automatically, which is essential. And it plugs right into CI/CD tools like GitHub Actions, so updating your site is, pretty smooth.
Makes sense.
Yeah.
For someone sketching this, any practical tips on choosing, say, the right app service size to start?
Yeah, try to estimate your traffic. Even a rough guess helps. Maybe 100 concurrent users at peak. That helps pick the right pricing tier. Visualize it. User request hits Front Door sends it to App Service might call an Azure function to do some work. See that flow.
Okay, sites hosted. Now, the core. Segment 2. Managing data and backend logic. Step 3 in our blueprint. This is really the engine room, isn't it? Products, orders, users. Getting this right is critical.
Absolutely critical. For storage, Azure has a great toolkit. For your structured, relational data user accounts, order histories, inventory accounts, Azure SQL Database is usually the workhorse. It scales well, it's super reliable, great for complex queries like show me products under $50. Now, if you're going truly global and need lightning fast reads and writes in multiple countries for certain data, maybe product availability, then Azure Cosmos DB is designed for that. It's a NoSQL option. For files, product images, videos, maybe PDF manuals, Azure Blob Storage is perfect. Cheap, scalable, and works great with a CDN. And one more thing, Azure Cache for Redis. Use this to cache frequently accessed data like popular product details, speeds things up a lot, and takes load off your main database.
Okay, storage sorted. What about the logic, the processes, like adding to cart, checking inventory, processing that payment?
That's often handled by Azure Functions. Or, for more complex step-by-step workflows, maybe Azure Logic Apps. So, example, customer clicks, add a cart. An Azure function could fire. That function checks inventory in Azure SQL, updates the cart data, maybe calculates shipping. All happens in milliseconds. It can also call out to third parties, like hitting the Stripe API to initiate a payment. It orchestrates these steps.
Right, so a design example could be front-end JavaScript calls an API endpoint hosted on an Azure function. That function talks to Azure SQL to get product details, maybe check inventory. It saves the order back to SQL. And the product images. They're stored in blob storage, just linked by a URL in the database record. What's the big why behind splitting it up like this? Why not just one big application?
The why. Good question. It's about reliability and scale. SQL Database gives you ACD transactions, guarantees that your order and inventory updates are consistent and complete, even if something hiccups. Super important. Splitting logic into functions means you can scale different parts independently. If checking inventory gets heavy load, you scale just that function. It handles traffic better. And for beginners, if you know SQL, starting with Azure SQL Database makes a lot of sense. It's familiar territory. Think about the future too. Data partitioning, maybe sharding orders by customer region later on, helps with massive scale. And definitely, add these data layers to your diagram, show how they connect.
Excellent point. Okay, core structure done. Front end, back end, data. But like you said, a house needs walls, locks, security. Step 4, networking security and integration. This feels absolutely crucial for e-commerce prime targets, right? Where do we start locking things down?
Absolutely paramount. Start with the network. Azure Virtual Network, or VNet, lets you carve out your own private space in Azure. Your app service, your database,
Wait.
they live inside this VNet, not directly exposed to the internet. Huge security win. Reduces the attack surface. We mentioned Azure CDN for images, but it's great for all static content, CSS, JavaScript. Caches it globally, faster loads, less strain on your app. And Azure Front Door again. That WAF web application firewall is your first line of defense against common web attacks. SQL injection, cross-site scripting. It blocks a lot of nasty stuff right at the edge.
Okay, that's the perimeter. What about protecting user accounts? Storing sensitive stuff like API keys?
Right. For logins, email password, sign in with Google, etc., you use Azure Active Directory, Azure AD. Specifically, it's B2C features usually. It handles all the complexity of identity management. For secrets, API keys, for your payment gateway, database passwords, connection strings, never ever put them in your code. Use Azure Key Vault. It stores them securely, and your application retrieves them at runtime. And for overall security posture management, Microsoft Defender for Cloud. It scans your resources, flags vulnerabilities, helps with compliance checks. It's like having a security guard watching over your whole Azure setup.
So securing inside Azure. But e-commerce relies on connecting out too, right? Payment processors, shipping carriers.
Right.
How do we manage those connections securely?
Yeah, integration is key. Azure Logic apps are great here for automating workflows between services. Like, after a successful payment, confirmed via Stripe API maybe, a Logic app can trigger to send a confirmation email via SendGrid and maybe update your inventory in an external system. If you're exposing your own APIs, say for partners or a mobile app, Azure API Management is the tool. It acts as a secure gateway, handles authentication, rate limiting, analytics for your APIs. And then there's the direct third-party integration. Calling Stripe, calling UPS, usually done via secure REST APIs, often using secret stored safely in Key Vault. Azure has connectors for many popular services too.
Okay, let's paint the full picture then. A user hits the site via Azure Front Door with its Wave. Front Door routes them to app service running inside a secure VNet. They log in using Azure AD. Their session details might leverage Key Vault indirectly. Checkout happens. An Azure function calls Stripe using a key from Key Vault. Payment succeeds. Then maybe a Logic app kicks off to send the confirmation email. That sounds pretty solid.
It is. It's a layered approach. DDoS protection from Front Door, network isolation with VNet, encrypted data, secure secret management with Key Vault, proper authentication with Azure AD, and a really crucial tip, least privilege. Your front-end web app probably shouldn't talk directly to the database. Let your back-end functions or APIs handle that. They have the specific permissions they need, nothing more. And yeah, draw these layers on your diagram. Show the VNet boundary, show front door at the edge, show Key Vault connected securely. It visually reinforces the security posture.
Right. We've built our secure house. Now, step 5, optimizing. Performance, reliability, cost. It's not enough to just build it. It needs to run well, stay up, and not cost a fortune. Back to that well-architected framework.
Exactly. Optimization is ongoing. For performance, we've touched on it. Auto-scaling in app service is huge. Don't set it and forget it. Monitor it. I remember this one client, their first big sales site just crawled because they hadn't configured auto-scaling properly. Lost sales. Costly mistake. So auto-scaling plus caching with Azure Cache for Redis for that frequently accessed data makes a massive difference to perceived speed. For reliability, think redundancy. Maybe deploying your app service to multiple regions using Azure Traffic Manager or Front Door for failover. If one region has issues, traffic goes elsewhere. And backups. Azure Backup for your databases, maybe blob storage snapshots, non-negotiable. And cost optimization. Use reserved instances for services with predictable usage, saves money over pay-as-you-go. Keep a close eye on your spending with Azure Cost Management. And, simple things like automatically shutting down dev test environments overnight can save a surprising amount.
So constant monitoring is key. How do we actually watch all this in real time, make sure things are running smoothly?
You'd use Azure Application Insights. It gives you incredibly detailed telemetry on your application's performance. Page load times, server response times, dependency calls, error rates, all there. And Azure Monitor complements that. It watches the underlying Azure infrastructure and can trigger alerts based on metrics or logs, like alert me if CPU usage stays above 90% for 5 minutes, or alert me if the site returns HTTP 500 errors.
Yeah.
Because, you said it earlier, e-commerce just cannot afford downtime, especially during peak times. Every minute down is money lost.
Okay, this has been incredibly detailed. For someone listening, maybe feeling a bit overwhelmed but inspired, what are the first practical steps after this deep dive? How do they start making this real?
Good question. First, get yourself a free Azure account. They usually give you some starting credit, like $200, which is great for playing around. Second, seriously, check out the Azure Architecture Center. Find those e-commerce reference architectures. Don't start from scratch. Third, once you have sketched out your own version based on what we discussed, use the well-architected review tool. It's an online assessment that asks you questions based on the framework and helps identify potential weaknesses in your design before you build.
And the big question always comes up, cost. It feels like all these services could add up fast. How do people approach that?
It's a valid concern. Remember, it's mostly pay-as-you-go. A basic app service might be pennies per hour. A very simple site could potentially run for, say, $50 a month. Maybe less, maybe more. Use the Azure pricing calculator online, plug in the services you're thinking of using, estimate your usage. It gives you a much better idea. And always look for free tiers for development and testing. Now, limitations and best practices. Azure scales massively, but you still need to think about your design's limits. Do those load estimates we talked about? Security. Encrypt everything sensitive both in transit, HTTPS, and at rest, database encryption, etc. Avoid public IP addresses on things like databases unless absolutely necessary and heavily firewalled. Common mistakes. Over-provisioning, choosing huge service tiers you don't need yet burns money, and ignoring backups. Seriously, don't ignore backups. Test your restore process, too. Keep asking yourself, what happens if traffic doubles? What happens if this service fails? Mentally test your design.
Sounds like continuous planning and vigilance are just as vital as the initial architecture design.
Absolutely. And don't forget the non-technical aspects, too. Accessibility, WCAG compliance, make sure everyone can use your site, and data privacy, be transparent, comply with regulations like GDPR. It's about trust. For next steps learning, Microsoft Learn has fantastic free modules on all these Azure services. Go deep on app service, functions, SQL database. And when you're ready to deploy for real, look into Azure DevOps or GitHub Actions for automating your build and release pipelines. Infrastructure as code is your friend there.
Wow. Okay, what a journey. We've gone from just the idea of an e-commerce site to sketching out a full theoretical blueprint on Azure, defining requirements, choosing compute, locking down data and security, optimizing. You really have a solid conceptual foundation now. So congratulations. You've essentially sketched out your first scalable e-commerce blueprint.
Yeah, and having this high-level plan before you start coding or clicking buttons in the Azure portal, it's just invaluable. It makes the actual implementation so much smoother, more robust, more efficient. You avoid costly mistakes later. It really turns what seems like a massive, daunting project into manageable, logical steps.
So here's a final thought for you to mull over. Now that you have this theoretical blueprint, this understanding, what's the one feature you prioritize building first to start bringing your specific e-commerce vision to life? And how might implementing that first feature influence some of these core architectural choices we discussed? Keep exploring, keep learning. Thanks for diving deep with us today.